Not gonna lie, this is probably my favourite question that I've ever written. Kai has a box of 20 chocolates. 15 of them are dark, and 5 of them are white. In class, and he probably didn't ask, he picks 2 out at random and decides to eat them. Construct a probability tree diagram for this experiment. So it's a probability tree diagram, so only after the outcomes and the probability of those outcomes, not all the different things that he could possibly choose from, because that would be a lot of drawing for us. So we have 2 options here. We have that he picked a dark chocolate, or he picked a white chocolate. And then again, he could either pick a dark chocolate or a white chocolate. Dark chocolate, white chocolate. Now, we have 20 options of the chocolate that we have. So the probability of a dark chocolate, first of all, is 15 out of 20. And therefore, this one has to be 5 out of 20. In case you guys haven't picked up on it, the 2 branches are always going to add up to 1. Because your probability has to equal 1. A little handy tip if you ever think, oh, well, they don't add up to 1, you've done something wrong. Now, what we have to consider with this experiment is, are we conducting this with or without replacement? Okay, well, once he picks the chocolate out of the box and eats it, you can't put it back. All right, so this experiment is being conducted without replacement. It's being conducted without replacement, so that means we have to consider now our new probabilities. If we've picked a dark chocolate, well, that means we have 1 less dark chocolate now to choose from. That changes to 14 out of 19. You take 1 dark chocolate away, you take one of your options away. All right? Other one, this now would be 5 out of 19. Because you still have all your white chocolates, you have 19 left over. And then for your other one, this would be 4 out of 19. Because you've chosen a white chocolate already, and this is 15 out of 19. And then finding all these probabilities, 2 white chocolates, well, that equals 5 out of 20 times 4 out of 19, which equals 1 out of 19. A white and a dark, 5 out of 20 times 15 out of 19. That's going to be 15 out of 76. 15 out of 20 times 5 out of 19, which equals 15 out of 76. And then 15 out of 20 times 14 out of 19. Well, that is equal to 21 out of 38. I've just done these in my calculator. That's how I've gotten the answers so quickly. And they would have been simplified. You would have gotten some different numbers if you tried doing this in your head. But again, that's just what I've gotten when I've put it into the calculator, and it's simplified for me. When you're doing these tree diagrams, you probably notice that these 2 solutions here are always the same. That's just because of the natures of these questions that we've had so far, only being 2 steps and only having 2 options. It's not always going to be like that, depending on what probabilities you have, how many outcomes you're choosing from. So don't just write the same one all the time. Figure them out, because something might change. So using the tree diagram, what's the probability that Kai chooses 2 of my white chocolates? Well, that is this little branch here, this one and that one. And we figured out 2 white chocolates. That just equals 1 out of 19. Actually, let's label them at the end. So this is 2 white, 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 dark, dark, white, dark, dark. Okay. What's the probability that he chooses 1 type of each chocolate? Well, that's just your dark white plus your white dark, which means you have 30 out of 76, which is 15 out of 38. You add 1576, 15 out of 76, or you could just times it by 2, which is how I cancelled out that common factor of the 2 in the denominator. It's 15 out of 38. What's the probability that you pick a white chocolate, given that the first was white chocolate? So, back up here. Given that the first was white chocolate, so here, what is my new probability of picking a white chocolate? If you can't see it, always go back to my formula, sorry. It's the probability of white, sorry, one white, given I've already chosen a white. Well, the probability of one white and choosing a white, well, that's the probability of white over white, of white and white, so that's just my 1 out of 19. And my probability of choosing a white the first time, well, that's just 5 out of 20. So that is going to give me 4 out of 19. You see also that 4 out of 19 is this here, right? If you could have seen that straight away, that is also the given probability, because we talked about that a little bit in class that day. We did tree diagrams like this. You could just put that answer straight down into there. It doesn't really matter. If you need the formula, absolutely go for it as well. Choosing at least one dark chocolate, given that the first one was dark chocolate. Let's think about this logically. If you pick a dark chocolate, what is the probability that you're going to have at least one dark chocolate when you finish? If you've already picked a dark chocolate, you are guaranteed to have a dark chocolate. That is going to just be 1. Has to be. You are guaranteed at least one dark chocolate if you chose a dark chocolate to begin with, okay? You could use the formula for that one if you really wanted, but sometimes it's just easier to think logically about these questions.